Coders, welcome. Let's get the C++ bowl rolling, right? An easy start. I want to talk a little bit about variable declaration, initialization, a basic program, some standard IOs, just to get us started with the basics. So, as you know by now, C++ was derived from the language C. C was very, very popular in the 70s. So popular that they were making operating systems with it, primarily Unix, but all the tools and even the C compiler was written in C. So it's not surprising that we'll see a lot of things that were invented in C expressed in C++ as well. In fact, you can see a lot of language structures that were made or invented in C in other languages as well. So learning C is basically a good exercise, but one which I wouldn't recommend unless you have spare time. You don't need to learn C to learn C++. You'll learn C as we go. So, but I just thought I'd mention that. Because I see a lot of people concentrating on learning C and then going over to C++. But that's kind of a waste of time, in my view at least, unless you really want to learn C and nothing else. But you might as well learn C++. Now, I've spoken about the different versions of C++, and I don't want to reiterate what I've already said, but I do think it's important that we sort of get a feel what the changes were, so I'm going to give a little overview of that. So what you see here, again, is very shortly the C++ versions that existed, 98, 03, 11, 14, and 17. Now, what were the changes like between all those versions? Now, from 98 to 03 was actually just a minor change. There were many more changes than I've listed here, but one of the more important ones is the way that values can be initialized. Don't worry if it doesn't mean anything to you right now. I'm sure it will later. Now, from 03 to 11 was actually a major change. Some people say that C++ became an entirely different language, which isn't exactly true, but R value references are a pretty major thing. Move semantics, which are going to be very important to us. Ranged fors, init lists, lambdas, smart pointers. All of these things are the essence of things that people argue about when they argue about C++. So this actually was a pretty big change. Now, from 11 to 14 was another minor change. We had return type deduction, which is a pretty powerful thing, and the make unique, which is a thing that we'll use in pointers again, but not as big of a change as the previous one. Now, then the change from 14 to 17 was another major one. Not as big as the one from 3 to 11, but definitely substantial. Structured bindings, all these terms, they sound like magic, but once I show you what they actually are, it's a lot less complicated than it sounds. Constructed template, argument deduction, and these standard library functions. So this is not for you to remember all of these things. This is just to give you an idea. If people talk about different versions of C++, then this is about what they are talking about. If you want to know the specifics, just Google C++ and you'll see all the changes, but most of them won't make any sense. These things will make sense when you run into a problem where this is the exact answer. And that's what you have to remember about C++. It's had, like many programmers over many years, run into the same problems, and then all of a sudden someone says, "Okay, we're gonna add this to the language to fix this or to help you write better code using this." So I'll show all of these, but it's up to you whether you want to use them or not. And in most cases, you won't need them. But there will be a case where you think, oh, I wish I could do this, or this would make my code faster. And then C++ might just have the answer. Also, some pretty influential people have had criticisms about C++ as well. And I mean, the people who've written C have said these things as well. Most of the criticisms are that it's too complex. There are mutually exclusive features. Some accuse C++ of having feature creep, like it never really solidifies around a version. There's always more and more being added. So don't just take my word for it. Don't just take the language lawyer's word for it. Also listen to the people who have criticism. So C++ may not be the answer to everything, right? It's not a holy grail. One of the things that I find important to note is that one of the criticisms that C++ has is that programmers are usually seen to use a specific subset of the language. They will ignore certain features, like unique pointers or like ownership of pointers or vector. Well, for vectors, I can't imagine that, but they'll decide that a certain functionality is too complex and they'll use a subset of it. So that is actually one that I think is true, because I don't think you should want to use every feature in the language. I mean, why would you? During the course of the tutorial, I'll be using some code by the one lone coder. I've mentioned him before. And we'll see that his use of the C++ features isn't that extensive. He makes nice small programs, but he doesn't use all the features. In fact, he's a proponent of not wanting to make things too complex, which I think is a good thing. Now, there's one thing that is important in what we're going to do, and that is how the way compiling and linking works. I just thought I draw a small diagram. If we have two files, this is a C++ file, and we're going to compile that, and out comes an object file. An object file is a compiled version of the source code, and that is added to the linker. Right? So after the compile phase, we get a link phase, and that will produce an executable. Sometimes we may even have a library file, and that will also be added to the linker. So one thing that I wanted to show you is the minimal C++ program. So this program does nothing, but it is the least that you need in a basic C++ program. Note that if you use C++ in a different environment like Unreal Engine, or you use it as part of something, you may not need a main function. But what you see here is we define a function called main, which has no arguments. It does nothing. It has no statements between these curly brackets. And at the end of the execution, it returns a value that is an integer, a whole number, to whatever called it. It can be the operating system, it can be a different program. And I've added some comments here to tell us what we're looking at. Now let's look at an example that actually does something. What we say usually is that the C++ program executes whatever that we do, this calculation, or that we run it. But formally, the computer does the execution, and the program specifies how. A C++ program is nothing more than just a series of characters, like a series of letters that has to adhere to the syntax rules of C++. The fact that it's spaced out like this and that it's organized is good for readability for us, but the computer doesn't care. Basically, what we have to do is learn the rules of C++, and we have to know a little bit about the computer that it runs on. We have to realize that variables that we store in memory have a specific size, which depends on the computer that we run on. But having a specific size, meaning that they take up a number of bytes in memory, they also have a maximum value. Now I have to realize that every variable that we store in memory has a memory place, of course. It has a value. It has a name. And it has a type. And with type, I mean it can be a whole number, it can be a character, it can be something that determines what the value can be. So these things, they are important to know about every variable that we have. Okay, so have a closer look at this code. We start the code with some comments. Now, comments, as we said, are only important for the reader, the human reader. And as you can see, there are different kinds of comments that I can use. If I start with slash and star, anything that comes after that is seen as a comment until I see a star and a slash. This way, I can add comments across multiple lines. As we go further down, we can also see the double slash. And this means that anything that comes after that until the end of the line is a comment. As soon as I go to a new line, then we are back to code again. So this is great for in-code comments. This include line means that we're including declarations of functions and facilities that we need for I/O streaming. This is the way to add functionality from libraries into your own code. Since we're going to do some input and output, we're going to use the I/O stream library, which is really part of the standard C++ library. The file that this points to is called a header file. This namespace line means that we're going to use the standard namespace. I'll be talking about that more in the future, so just ignore it for now. As you can see, we have our main function again, and we have some statements here, and at the end, we return 0 to whoever called us. Now, if I concentrate on these lines here, and the one here, this is where we declare the use of two variables called coordinate and step. And we are calling them coordinate and step, and we're making them of the type int, which is short for integer or whole numbers. Now, as you can see here, we also have an int called forward. And forward is initialized as the sum of coordinate plus step. Then after the comma, there is another integer, just like we did step over here. We have another variable here called backward, which is initialized here with step subtracted from coordinate. Now we could have written this in a few different ways. We could have split this over a different line. We could have ended the statement with a semicolon, then added int here, and then we would have had the same thing. End the statement there, add an int there, end the statement there, add an int there. This has exactly the same effect. So how you write your code, it doesn't really matter for the compiler sometimes, but it's better. It can be better for readability to distribute the code over several lines. What we also could have done is take this and say forward equals coordinate plus step. Oh, added 2 there. So this means that we've declared our variable forward here. We haven't initialized it, but we've assigned coordinate plus step later. So there's a difference between initializing and assigning. Now also note that these declarations appear after some of the other statements. So a declaration is basically just like a statement, and you can place them anywhere in the code. What's important to remember is that as soon as you declare variables, the compiler will reserve memory space for them. Now, because we've used the IOStream library, we can use this cout. Cout is basically streamed I/O, and this is the standard output channel. Just think of it in this case as a console application, and the display being the output. So this string is just streamed to the output channel. Basically, it's being printed on the screen. But this streaming operator, the 2 left brackets, they are pointing towards the cout, so they are going out. There's also a cin, which means input, which is the standard input channel, which is usually the keyboard. And the standard input from the keyboard is streamed towards coordinate and then to step. So what this program does is it asks the user to enter a coordinate and a step. So suppose we're writing a game and the player is advancing either to the left or to the right. And normally this would go automatically, but now for the sake of this example, we're entering a coordinate and a step. And we want to see the result of that. Also, because we want the result to be positive, we want to square the result. Not that it makes sense, but just bear with me. So this line prints out a string. We declare 2 variables and we read the input from the standard input. And we put it in coordinate and into step. Then we have another variable. We add whatever we've entered, coordinate and step. And the backward is coordinate minus step. So we calculate both ways. Then we introduce a new variable called u, which is forward times forward, or forward squared, and an int v, which is backward times backward, which is backward squared. So if any of these numbers were negative before, after the square operation, they are now positive. And we output the result. We output the result to the standard out. We print a string, square of forward, another out, then the variable u, another out, and then end L. End L is end of line. And we have another one of those, but then for the variable v. So let's see what happens when we run this. So enter a coordinate and a step. So we're going to say coordinate 15, then a space, and a step 2. And we press enter. Now the square of forward is 289, and the square of backward is 169. So this is the result of our little program. Now besides working with numbers, we can also do the same thing with strings. Let's have a look. Now in this example, you can see that we again use IOStream because we're doing output, but we're also using string in this case. And in the code, you can see that we now have a type called string. Now we're declaring 2 variables called player1 and player2, and they are both strings. Again, we print the string, enter a name for player1 and player2, and at the end of the line, we give an end line. Now we use another function called getLine here. The reason we do that is because we can't use cin for this. If we do that, then any spaces at the start of the string won't be stored in the variable. And any spaces or tabs at the end will end the line. So we use getLine to get from cin a value. We place that in player 1. And when we see a new line, which is this character here, then we end the input. But this does not get included in the player 1 variable. Then we print a string, output in alphabetical order. As you can see, we don't use endl here at the end, but we use the \n. So there are a number of these special characters. There's one for tab, and there's a few that I'll mention later, but it's good to get to learn this new line one. Now what we do here, we see if the name of player 1 is smaller or equal than player 2, then we print a string with player 1 first, an end line, and then player 2. Otherwise, else, we print the same string, but then first player 2 and then player 1. So basically what we're doing, we're comparing whatever we typed as names for player 1 and player 2. This operator apparently works on strings. Let's have a look. So if I typed Nathan and Naboo, as you can see, Naboo is printed before Nathan because the third character of Naboo is an A, and the third character in Nathan is a T. So this works. So we took a few small steps into C++. We've seen a basic program. We've seen IOStream. We've seen the way that we can get some stuff from the keyboard and print something. And more importantly, we've seen some variables, we've seen some initializations, and some declarations. So the key thing to take away from this first lesson is just to get a feel for what C++ looks like and some basic stuff about variables. So I hope you liked it, and I hope to see you next time. Bye-bye.